Hi everyone. I am here with one Accenture coding question that was given on 20th September 2023. So this is about generating the count of meta numbers in a given range. So what is a meta number? Let us understand the problem. Let me go through the problem. Bhavana is given a number n. She has to print the number of meta numbers in the range 1 to n. Meta number is the number divisible by 1, 2, 4 and 8 but not divisible by 10. Can you help Bhavana to print the number of meta numbers in the given range? Okay, so n will be given. N is given as input and we have to produce the number of meta numbers in the range 1 to given n. What is the constraint here? The constraint is given as n varies from 1 to 10 power 9. So you please watch this one. So 10 power 9 is the biggest number and we must attempt to write an optimized solution. That is one indication here. So the sample inputs are given like 20, n is 20. The number of meta numbers in the range 1 to 20 are 8 and 16. So that's why the output is 2. Then for another input 13, the number of meta numbers in the range 1 to 13 is 1. So 8 is the only meta number in the range 1 to 13. So that is the understanding here. Now, so to manage time of the video, so I have already wrote the solutions so that you can quickly have a grasp of it. First I have attempted with direct approach. Normally people will write this approach which will consume a lot of time complexity. Let us go through the solution. We have to read n. The input is to be read from the keyboard. Why? Because they have particularly mentioned like input is to be read from stdin. Stdin stand for standard input. So count is initially taken as 0. Then we will proceed from 0 to n plus 1. So here I have given 0. No problem. Even we can start with 1. No. So let me consider this as 1. As they have mentioned, it n ranges from 1 to 10 power 9. Let me start with 1. No problem. If I% 2 equal to 0, that means if the number is divisible by 2 and if the number is divisible by 4 and if the number is divisible by 8 and if the number is not divisible by 10, such number is to be treated as a meta number and in that case count will be incremented by 1. Then finally print count. So this is the linear approach or straightforward approach or brute force approach. We can give any name for this one. I labeled it like direct approach. This will work out and let us run and see whether it clears the sample test cases or not. So the input given is 20. What is the expected output? 2. Yes, our code is generating the correct output. Next, let me give another input that is 13. And what is the output we must get? 1. Okay. It is working for the sample test cases. Let me try with another number. Let me give 100. 10. It is perfect. It is working perfect. Then what is the concern here? What is the concern here? We have observed in the constraint that n can go up to 10 power 9. 10 power 9 is a huge number and we must focus on reducing the time complexity. So if I follow this direct approach, what is the time complexity of this? The time complexity is big O of n. The time complexity is big O of n. So we have to reduce this. Okay, so then only it can clear all the test cases. Most of the people will write this direct approach and they claim this as the solution for this one. So for this problem, they look at optimization of the code. Okay, now, so this is the time complexity of this approach, direct approach. Let me try to improvise this one, optimize this one. I have considered one approach. We all know that the number divisible by 1, 2, 4, 6, sorry, 1, 2, 4 and 8 is nothing but that number must be divisible by 8. So let me explain it further. Let me take LCM of 1, 2, 4 and 8. The LCM of 1, 2, 4 and 8 is 8. So if I have to see or if I have to check any number that is divisible by all these numbers, obviously that should be divisible by 8. Okay. So that's why I am considering the increment of 8 for each iteration. So you see, in optimized approach 1, I am reading the input n. Initially count is set to 0. For I in 0, I am starting with 8. We clearly know that up to 8 there is no other number that is divisible by 8 in between 1 and 10. So directly I am starting with 8 and it will go up to n plus 1, and after each iteration I am incrementing it by 8. Then what is another condition they have given? That number which is divisible by 8 should not be divisible by 10. So that condition we are applying here. If I% 10 is not equal to 0, increment count by 1. Okay. So finally print count. So let me try with the sample input whether this approach works or not. 20, it is producing expected output. Let me try with another input, 13, it must give 1. Yes, it is giving. Let me try another input, 100, it is giving 10. Okay, it is working perfect. So when compared to the previous approach, which is direct approach, this reduces the time complexity. Now from big O of n, I brought down the time complexity to big O of n by 8. So what is the time complexity of this approach? Big O of n by 8. Of course, there is no representation like n by 8, n by 10, etc. I would like to show you that it consumes lesser time compared to the previous approach. Okay, n by 8. So it is optimizing. It is an optimized version of the previous one. This will reduce the time complexity. Is this sufficient? No. I have arrived at one more direct approach which almost takes constant time complexity. Let me introduce that method to you. This is optimized approach 2. Here I will be taking n from the user. N is read. Then one observation I made here is, for example, in the range 1 to 10, definitely there will be one number that is divisible by 8. From 10 to 20, there is one number divisible by 8. From 20 to 30, there will be one number. So likewise, if 1000 is given, if n is given as 1000, how many numbers will be available in that range that are divisible by 8? Obviously 100. Okay, so for every 1 to 10 range, there will be one number available that will be divisible by 8. So based on that observation, I am setting count to n floor division 10. N floor division in the sense, what is the meaning of floor division in Python? It will consider only the integer portion of the result, integer portion of the division. So n floor division 10, it will take that one. Then I am taking some temporary variables. X is n modulo division 10, y is n divided by 10. Then for I in range, so this is to check, for example, if 1002 is given as n, up to 1000 I clearly know that 100 is the number count of meta numbers in the range 1 to 1000. Okay, that is clear. Then there will be remainder part, no? For example, that may be 2, that may be 4, that may be 6, that may be 8, which will be added to the original number that can be divisible by 8. So to track those, to track that one, I am giving for I in range 0, x plus 1. X plus 1 is, x is what? The remainder portion. Suppose if the given number is 1002, that x will be 2. 2 plus 1, comma 2. Every time we are incrementing by 2. So we clearly know that the number which is divisible by 8 will be obviously an even number. Then y plus I percent 8 equal to 0. If any number is divisible by 8, what is this y? added to 1000. 1000 plus 2, if that is divisible by 8, increment count by 1. If 1002 is not divisible by 8, count will remain the same. Okay. So likewise we will check with at most 4 iterations here. Then print count. Okay. This is the efficient method which will almost consider constant time complexity. Constant time complexity. What is constant time complexity? It is represented as big O of 1. Big O of 1 here in this case at maximum big O of 4 iterations may be taken. At maximum 4 iterations. This is almost negligible. We can say that it consumes constant time complexity, nothing but big O of 1. So this is the efficient approach one expects for a large range of numbers like 1 to 10 power 9. Now, let me run this code. For example, 1002. What is the output I am getting? Yes, 100. Next, let me run this again. Let me take 108. It is 11. It is 11. Up to, for example, say up to 100, there will be 10 numbers that are divisible by 8, and this is okay. So is 108 divisible by 8? Yes. 8 ones 28. Is 108 divisible by 8? I don't think so. Let me check with another number. 104. How many? 10. Yes. 108 is divisible by 4. Yeah. Sorry, divisible by 8. Yeah, we got it. Let me check with another number. For example, 20. Yes, we got it. Let me check with another number. This is like 13. 1. Yes, we are getting it. Okay. So this is how we have to solve this problem. When there is larger input given, we must focus on optimizing the solution. If you write direct approach, if you write a solution using direct approach, some test cases may not be cleared. What are those test cases? So these recruitment companies, they will be designing 1 or 2 test cases to check for the time complexity. Okay, so in such cases, 1 or 2 test cases may be failed for direct approach. So how to avoid that situation? Then we have to write optimized solutions. For this solution, for this problem, optimized approach 2 is very much suitable. Okay, so I hope you understood the logic presented here. So if you have understood, please like the video, share it with your friends and subscribe. Thank you.